Let's talk about radiation. Radiation is a fundamental physical phenomenon that occurs in various forms and has significant implications across multiple fields, including physics, medicine, and environmental science. So, what is radiation? Radiation is a fundamental concept in physics that refers to the emission and propagation of energy in the form of particles or waves through space or a material medium. It encompasses a wide range of phenomena, including electromagnetic radiation, such as light and X-rays, and particle radiation, such as alpha and beta particles. So, radiation can be classified into two types, which are ionizing radiation and non-ionizing radiation. So, what is ionizing radiation? Ionizing radiation has enough energy to remove tightly bound electrons from atoms, that is, to ionize them. Ionizing radiation includes alpha particles, beta particles, gamma rays, and X-rays. Ionizing radiation can cause damage to living tissue, which is particularly relevant in medical or nuclear contexts. So in the case of non-ionizing radiation, this includes lower energy forms such as the ultraviolet light, visible light, infrared radiation, microwaves, and radio waves. Non-ionizing radiation typically does not carry enough energy to ionize atoms. So let's talk about background radiation. What is background radiation? Background radiation refers to the ionizing radiation that is present in the environment, originating from both natural and artificial sources. It is always present and varies depending on geographical location, altitude, and local geology. So, what are the sources of background radiation? Natural background radiation arises from cosmic rays, that is radiation from outer space, terrestrial sources, which includes radioactive materials in the earth, and internal sources, which includes radioactive isotopes within the human body. So let's look at the various natural sources of background radiation. Number one, cosmic radiation. These originate from outer space and interact with the Earth's atmosphere. Higher altitudes and locations with less atmospheric shielding, e.g. mountains, do experience increased cosmic radiation exposure. High energy particles from outer space that interact with the Earth's atmosphere. In fact, airline passengers and crew receive a higher dose of cosmic radiation due to the fact that they have increased exposure at high altitudes. The second one is terrestrial radiation. Naturally occurring radioactive isotopes in the Earth's crust, such as uranium, thorium, and radon, contribute to background radiation. Radioactive elements like uranium, thorium, and radon that are present in the soil and rocks. Radon gas in particular can accumulate in homes and pose health risk. In fact, some construction materials such as granites and certain types of concretes and bricks can contain naturally occurring radioactive materials and contribute to radiation exposure. Then the third one is the internal radiation. The human body itself contains some naturally radioactive isotopes, such as potassium-40 and carbon-14. These contribute to internal radiation exposure. So, in my next video, we'll be looking at various sources of man-made background radiation and how they can be minimized, how they can be controlled, and the effect they have on the surrounding. So stay tuned, watch out, God bless you all.